Okay, so the last little thing we're going to look at, and this is just another example. The gist of it was in example 1 there. So systems of equations can be used to make equations of line, to make those linear equations, those y equal mx plus b. So remember, when we're talking about that mx plus b, your m is the slope, and your y-intercept is the b value. So just keeping that in mind. Remember that from Unit 4 is when we did that. So if we consider the line that passes through these points, old school, we would go ahead, do change in y over change in x, find the slope, take that, plug that into one of the equations, plug that in one of the points into the equation, and solve for b, blah, 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 like you did in your take-home quizzes. However, the difference here, though, is we're going to use a different method. We're going to use a system of equations. We're going to use 2 equations to solve this. This is kind of cool. You might like it. So again, I'm going to start off with that y equals mx plus b and the fact that they give me 2 points to make some equations. So first point I'm going to use is -2, 11. That's an x and that's a y. So the first equation I can come up with is -11 is equal to m times -2 plus b. Simplify that a little bit because m times -2 is just really written as -2m, and that looks way more normal. And my second point I can use here, let's get a different color, is this guy. So my second equation I can make is 4 equals m times x plus b. M times 3 is just 3m plus b. All right, so now I have equations, and here everything is lined up. My constant is isolated, and my 2 variables are over here. So now let's line them up vertically. So -11 is equal to -2m plus b, and then I'll just rewrite that green one. 4 is equal to 3m plus b. So my b's already have matching coefficients of 1. The only problem is that if I add them right now, I would get 2b instead of 0b. So I need to change one of those signs to become a negative. So I'm just going to multiply this top equation by a -1, giving that to all 3 pieces. Changing that equation to be +11 is equal to +2m minus b. Now that I have those additive inverses that I'll highlight, I can go ahead and add those 2 equations together. And when I'm doing this, I'm only looking at these 2. That's not a good idea, because that's not going to move the whole thing. Either way. So 4 plus 11 is 15. 3m plus 2m is 5m, and my b's cancel out just like I wanted them to. Final step, I can divide both sides by 5 to get my m, aka my slope of 15 divided by 5 is 3. So now that I have that m value, I can go back, plug it in, and find the missing b value to one of my equations. So I'm just going to use the green equation because it looks like it has smaller numbers. So 4 is equal to 3m plus b. In for m, I'm putting 3, not to be confused with the 3 that's already there. 3 times 3 is 9, plus b, minus 9 to both sides, because that's the opposite of a positive being added. B is equal to 9 fourths. 4 minus 9 is -5. So we have an m value. So we have a slope that's equal to 3 and a y-intercept that's equal to -5. So just another fun thing you can do with systems of equations. Boom.